So, hello everyone and welcome to this new video. Today's video is like a video that comes in three parts, in the sense that it comes in three parts. First of all, I want to talk about this filter, the spawning space counter 1.0, which counts spawning spaces. Secondly, I want to go a bit more technical for the programmers or people who at least have a bit of programming experience out there, and talk about the development process of behind the filter. And finally, I also want to talk bit about the TNT quarry video I made back in September and, the general research I said I was going to work on and also did for a bit. However, first, let's focus on the filter. We have a filter called spawning space counter 1.0. You have settings, you filter, it gives you the amount of spawning spaces in your selection. Like that. Pretty simple. Actually, this is the default setting. So, now here we have a perimeter. And I selected a pretty reasonable area, 320 by 320 by 80 blocks. It's a quad height with a perimeter. All the water has been drained, so there's lots of spawning spaces on the surface. And as a result, we have 144,000 spawning spaces, approximately, which can spawn 2 high mobs, or lower, of course. So yeah, pretty much we have that many spawning spaces, spots where you have 2 blocks of spawnable space with 1 surface block under it, with a light level of 7 or lower, and we're not counting skylights. So as a result, the surface also count as spawning spaces. So if we filter without that, then we get 100,000 less, which makes sense, I guess, considering that there is a lot of space here on the surface. But it depends a bit on whether or not you want your perimeter to work at all times or during the day. So I exclude the option. So that explains this option. I think the spawn height and maximum light level options are also pretty clear. The print positions option is fairly useful if you are using a command line or terminal like I am, because then if you do this, then it will simply spam your terminal with a big list. Okay, maybe this wasn't the best idea because this list, there we go, it's on. It will just spam your entire terminal with a list of spawning spaces. So this is not something you would do at this point, but probably this would be useful if you decide to light up caves manually or something and you're trying to figure out where those last spawning spots are, like if there's less than 100 or maybe less than 1,000 left. So yeah, then you just can then you just have to filter print the positions into your command line and read them from there. Now, if you have trouble starting MCEdit from command line or something, then that's fine. Then you can also use this final feature, which allows you to save the spawning positions to a text document by providing a path relative to your filters folder. So if I write test.txt here, I'm not actually going to do it because I'm too lazy to clean it up afterwards. But if you were to filter now, then you would create a test.txt text file inside of your filters folder. You can also, of course, use stuff like folder name /txt test and that kind of stuff. The precise syntax depends a bit on the operating system you use. I think on Windows they use backslashes instead. I don't know. Anyway, that explains all of these features, and there's one left, being the version. Now, spawning mechanics changed a bit in between versions. This filter is pretty basic in the sense that it just looks for a block out of a spawnable list and a block out of a bottom spawnable space list. So it looks for a block out of a spawnable surface list, then a block out of a spawnable bottom space list, then a block out of a spawnable space list. So yeah, the bottom block is special because of one exception being snow layers. If you have 0 snow layers, mobs can spawn inside of them, but only if they're on the bottom, and they do block mob spawns on higher levels. And also, mobs don't seem to be able to spawn on them if there's no block under it. No spawnable surface under it. So as a result, the algorithm is a bit weird than that. But anyway, that's how the rough algorithm works, and what the version does is it affects those lists for a bit. So for example, 1.8, you couldn't spawn stuff on top of pistons, and of course you couldn't spawn stuff on top of lots of blocks which weren't there yet. So pretty much what the version just adjusts those data structures for a bit to represent the version, mostly by adding new blocks or adding new blocks to the lists, to the data structures, or whatever you want to call them. They're not actually lists in the program. But also in certain cases, like 1.8 to 1.9, for example, there were changes to all blocks as well. And I also try to take those into account. However, as many of you probably know, I am kind of out of the loop with Minecraft, technical Minecraft these days, also Minecraft perhaps in general. So as a result, my stuff may be wrong for a bit. As a result, I would very much appreciate it if people were to check the source code for my filter. It's just a Python script. Anyone can read it. The constant data structures are defined pretty close to the top. I think if you have a bit of programming experience, you know, you should be able to see what I'm doing and how they work. And it would be nice if you could point out any errors I made there, because it's definitely possible. I did not test every block on every data value, on every version with every data value. That would be a bit insane. So yeah, it would be very nice if you could check those things for me and tell me if there's something missing or something wrong, whatever. Now that goes and brings us to the second part of the video for the people who know a bit about programming. Because you may think, well, this filter is pretty easy to make, like you just iterate through everything and then you're done, right? Yeah. Well, that's how I started with this filter all the way back in like October 2015 or something. I don't know, it was like fall of 2015, let's put it that way. But that's pretty slow once you have to loop through, I don't know, tier 20, oh look, there it goes, 8 million blocks. Oh yes, one thing I forgot to mention, sorry. For this thing to work, the entire space needs to be inside of, you need to have at least enough space for at least one spawning space inside of your section. So for example, if you are looking for too high, then yeah, it's going to complain because there's only a one high spawning space there. And it will be fine. So for example, if we have 5, then it will demand that we at least have a spawning space, that we have a selection box which is at least 6 high, pretty much. So this won't work, and this will. So yeah, getting back to that. So you could just count all spawning spaces by iterating through everything. That's cool and all, but it's going to be very slow. You're going to check every block. Well, say you have a spawning space, a spawning height of n, you're going to check every block n plus 1 times or something, or roughly speaking, in the limit. For an infinitely large selection box, at least. So that's not very good, is it? You're going to check every block a lot of times, and you're going to check a lot of spots where you kind of could already guess that there can't be a spawning station because there's no surface block under there, and you just already checked that. So that led me to create another algorithm in fall of 2015, which was based on a finite state machine, you could say, or deterministic finite automaton, whatever term you like the most, where I pretty much would keep a small memory of the blocks I previously checked, and jump a couple of blocks ahead or backward through one stack of blocks, through one column of blocks, depending on that. So yeah, because for example, as long as you see, for example, if you see an air block, damn it. Say we have this stack, right? If you this block, okay, this isn't great. Fine, there we go. So here it goes through something, or at least I hoped. There we go. It just goes through stuff. So right now here it realizes, okay, surface block, then it checks air block. Okay, we've got a spawning space, fine. But now since we never have a surface block, then we might as well just jump to 3, because we're gonna, I don't know exactly how it worked. It's over a year ago, but either way, it used some very clever stuff for states, and that allowed it to only check each block at most once and still skip a lot of stuff. And for some reason, my internet is very laggy at the moment, or is it just me? Anyway, so yeah, you could do some cool stuff with that. It tried to take into account that that air blocks and like solid blocks were often clustered, as well as the fact that once your skylight is at 15, then there can't be any spawnable blocks above that, I think. Or did they change that? I don't know. Either way, it was an algorithm which was pretty good, but we don't use it anymore. Why? Because I got a tip from Matt and Bert. I will link to his website down in the description. Because I talked to him about it, and he was like, "Oh yeah, that's cool. But have you actually tried using NumPy for this? And just still going through the hard loops you used to do. Because his idea was that, fine, you've got this great algorithm now, but it's still running in Python. Python is an interpreted language, very high level, takes ages to run. If you use NumPy to do the heavy loops, then you can actually push the heavy loops down to the C layer because some NumPy is a library implemented in C. So whenever you do a function call, it will be handled by C instructions, which don't need to be interpreted or anything. So that's a lot faster. So maybe the worst algorithm could be compensated by just the better general running execution time of C versus Python. And took a long time. I took until September or August of last year, I think, of 2016. But I finally got around to it when I started looking into this whole quarry project, because this filter was turning out to be quite useful. And he was right. This filter right now uses a pretty naive algorithm, but just by using NumPy for the heavy operations, it's about 11 to 12 times faster for perimeter-sized selections. So yeah, sometimes you can use cool computer science methods, and sometimes it's just about going low level. So that's the second part of this video kind of covered. So just for the programmers out there, NumPy is cool, I guess. Because like right now, I'm not sure, but I think this whole perimeter can be covered in about 2 seconds or something, whereas it used to take, I think it was like 1.8 seconds, whereas it used to take 19 seconds or 20 seconds with the old method. Something like that. So yeah, that's the second part of the video. So I think I'm pretty perhaps proud is a bit of an overstatement considering NumPy is doing all of the work, but it's still fun that it's so quick. Because I think people may actually use it in this kind of setting, even though it's quite big. Anyway, moving on to the third part of this video, which is about alright, TNT quarry and stuff. Yeah, so back in September I made a video where I showed off some TNT quarry stuff, and I was like, alright, in the next video I'll start to do a big comparison and such. And I started working on research for a bit, but the semester started and I got busy with school and I got less interested in technical Minecraft as I've often have been in the past year, 2 years, I don't know. It's been a while already, hasn't it? And as a result, I never really got around to properly working on that, and by this time really, I've heard that Jewe, I will link his channel down in the description, has already done some improvements to the stuff I showed, along with some other people, I think. And also there's, for example, Mango, who released a video 1 or 2 weeks ago, also linked to that video, which is pretty much a perfect, well, not perfect. It's a very good quarry. It uses 1.11 observers, but you could probably implement it as well using alt Slimestone. Maybe I'll work on that someday, no promises. But yeah, pretty much it's a full quarry, you could say, as in it has a water clearing unit and a TNT quarry unit. So it's way better than the stuff I was featuring anyway. TNT quarry unit was bidirectional. It was just great. Tridirectional actually. Sorry, went left, right, and also down. Horizontal to bidirectional and then also down. So that was. Yeah, pretty cool. Like, maybe there are some improvements to be made there. Maybe I'll look into that one day. Maybe there are improvements I can make. I don't know. No, don't make any promises, but I'm just trying to say here is that I've kind of lost interest in that project, and I just wanted to... Part of the reason why I wanted to make this video was just to give a proper ending to that. I hope you don't mind. But, yeah, other people have done better work than me in the meanwhile, so I don't really see a point with going on with what I was working on back then, just for the sake of completion. No, I'm not going to do that. With all that being said, I think it's finally time to wrap up this video. Thanks for watching. Sorry for the length, but try to focus on the important stuff. Anyway, as already said, thanks for watching, and I hope I will see you in another video.